Namaste. Today, we are talking about the other two different phenomena of light. Okay. Till now, in the previous classes, we studied about the phenomena of light, that is, phenomena of light like what we studied before that. We studied the phenomena of light like reflection, correct or not? Reflection. What do you mean by reflection? Whenever a light ray enters into the boundary or surface, smooth surface, it bounces back. It comes to the original medium. That is known as reflection. Next is what? Next you studied the one thing, one more phenomena, that is refraction of light. Correct? So what is meant by refraction? Whenever a light ray from one medium to another medium enters, then what happens? There is a bending up of light takes place. This is known as refraction. Why the bending up of light takes place? Due to the difference in the speed of light. Speed of light is maximum in air or vacuum, and it decreases whenever it enters into the denser medium. What is the meaning of rarer and denser medium? So it depends upon what this is. Air is a rarer medium when compared to liquid, and liquid is a denser medium when compared to air. Same thing. So if it is a solid medium, air is a rarer medium when compared to liquid, and liquid is the rarer medium when compared to solid. Rarer and denser medium, how? Depending upon the arrangement of molecules. In air, how the molecules will be arranged? Like this. Correct or not? In the liquid, molecules are arranged like this. Okay. So, like this. Now, in the solid medium, how the molecules are arranged? They are tightly packed. Correct or not? So this is density of the solid is more when compared to liquid, compared to air also. So solid is the denser medium when compared to liquid and air. Now, so if it like this, so bending up of light takes place depending upon what? Depending upon the medium, density of the medium, and that is depending upon the change in the speed of the light okay, in the medium. Now, what we are studying today, we are studying two more phenomena of light, that is dispersion and scattering of light. Now, let us see the refraction of a light through a glass prism. What is the meaning? Till now, we studied the refraction in the parallel glass plate. Okay, parallel glass plate or parallel medium. So, the water or solid like that. But now, what we are doing is we are studying in a reflection of light through a glass prism. The glass prism, how it looks like? See, in the picture it is given, correct or not? How it looks like? It is actually it is a plane. It is in a plane, but it is in a, if you take in a solid sphere, it is a solid sphere. Okay, that is consists of two rectangular spaces, three rectangular spaces bound to each other, and two triangular bases. Okay, two triangular bases. This is what this combination of a glass item is known as a glass prism. Okay, glass prism. Now, suppose if a white light enters into the glass prism, okay, this glass prism is it is a triangular glass prism. It has equal sides. Okay, so now what happens if it is this is known as what? This is known as the angle of the prism. This angle is known as angle of the prism. Suppose this is the base of the prism. Okay, this is the base of the prism. Now what happens if a light ray enters from medium air like this to the glass? It is very, very important. It is the glass, and you know that refractive index of the glass is 1.5 and refractive index of the air is 1. Correct? So whenever it enters like this, then what happens? It bends like this because of it travels from air to medium like this. Okay, it will bend like this. And again, what happens? It is one phase. It is we can write. You can write that as angle of incidence, and here it is one more normal. If you draw like this, then what happens? Where is the angle of refraction? Here it is the angle of refraction. This angle is you will write like this. Okay, this is one more angle of incidence. This is I1 and I2, because this refracted ray becomes what? Refracted ray becomes the angle of incidence for the other phase. This is the first phase. It is ABC if you write. Okay, light is incident on AB phase. Okay, it bends to, that is, refraction takes place inside the prism, and that refracted ray hits the other face of the prism, so that it emerges out the prism like this. See, this is the end, that is a emergent ray. This is known as emergent ray. This is the angle of one more angle of incidence. This is I2 we will call. Okay. Now what the angle? Okay. What the the angle between the emergent ray and the this normal is known as angle of emergence. Angle of emergence, E, you can say. Okay. Now, so now what happens if you extend the emergent ray and the incident ray like this, it will meet somewhere here, correct or not? This is known as angle of deviation. This is a big angle. Means what? Without the prism, light might have traveled straight line, correct or not? That is, light might have traveled straight line in that is, but due to this one, it has bent. That amount of bending is known as angle of deviation. Okay, now, so this is a refracted ray is straight, parallel to the, inside the prism, the refracted ray is parallel to the base of the prism. So what happens? It is once it is bent here, okay, at this phase AB, and once more it bent at the phase AC, twice it bent. Okay. To taking this prism as an example. Why we are taking this prism? Because we are discussing a different phenomena of light, that is known as dispersion of light. Okay, this dispersion of light was found out by dispersion of light. You have to write like this only. Okay, not only in the examination, if they ask what is the phenomena the prism will exhibit, that is known as dispersion of light. Okay, so here it is. This dispersion of light. This dispersion of light was found out by Newton, scientist Isaac Newton. How he demonstrated the experiment, I will tell you. Okay, what he observed that, okay, he took one rectangular prism like this, and he made to fall a white light through that one. Okay, he took one prism like this, and he made to fall a white light. White light means what? White light means the light from the sun, right, directly. Okay, direct sunlight is known. It is in a white color. You will call it as, it is a white color. So whenever a beam of light enters into the prism, okay, one face of the prism, then what happens inside? What happens? It is refracted here. Okay, it is refracted, and here what happens is it is dispersed into different, splitting up of light takes place. That is known as dispersion. So whenever diffracted like this, then what happens? We know that white light consists of 7 colors. Okay, this 7 colors will be splitted like this here as blue, red, and green. Correct? Not like this. It will splits up. Okay, inside the prism it happens. Why it happens? Because the refractive, so white light consists of 7 colors, I told you. This white light, the 7 colors having different wavelengths. And due to these different wavelengths, these different colors will travel with a different speed in a different medium. But here in the air, okay, it appears what? Appears as white, because the speed of the light in air is constant. All the wavelengths all the colors will have the same speed. But whenever it enters into the medium, then automatically the speed changes. Speed of the different colors will change. So first it is what? Speed of the red light is 2 more, so that it bends lighter. This is what? This is the emergent ray. Emergent ray consists of, okay, if you take a white light, a monochromatic light means single light, the emergent ray is what? Only one light. Okay, if you consider a white light, that is from the sunlight, okay, the emergent ray is what? Emergent ray from the other side of the prism is what? 7. It splits up into how many colors? Plus 7 colors, and it is like this. Okay, and this 7 color, this one is what? The arrangement of this one is, we will call it as Vibgayar. What is Vibgayar? Colors, different colors. Correct? What does this V means? Violet, indigo, blue, green, yellow, orange, and red. I told red is the one which bends least, correct? Which red is the one color which bends least because of what? Because it is a speed is more. And here it is violet is the one, violet. It's almost near to the base of the prism. Okay, almost near to the, it bends towards the base of the prism. Why? Because the speed of the violet color and hence the blue color. Okay, violet and blue together. So it is having what? It is having the less speed. So depending upon this, what happens? Splitting up of the colors takes place. Splitting up of a white color takes place inside a glass prism. This will not happen in the parallel prism. Okay, rectangular prism, it will not happen. It happens because only in the triangular prism. It happens only in the triangular prism. Splitting up of light into different, depending upon the angle of the prism, it happens like this. Splitting up of light into different color, its constituent colors. Okay, into its constituent colors. Its constituent colors. And this is known as, this constituent colors is there, no? Colors are there, no? That is known as spectrum of light. Okay, spectrum means what? It is a combination of different colors. Okay, different wavelengths. Okay, that's why it is known as a spectrum of light. Okay, so this splitting up of light, whenever it enters into the glass medium like prism, okay, that is known as the dispersion of light. Splitting up of light or bending, that is splitting up of light is also due to refraction only. Okay, this is known as dispersion of light. Splitting up of light into its constituent colors. Dispersion of light. This was, I told this phenomena was demonstrated by Newton. What he has done, he took one prism and he observed this one. One more experiment he has done. What is that? So you can see the clear picture of the spectrum here. Okay, I will tell you how it shows. See. So this is the clear picture of the spectrum. The band of light. See, this is known as a band of light. See how it is, correct or not? So violet, indigo, blue, and everything. Okay, it is a band of 7 colors. Band of 7 colors called as spectrum. So how it bends? See, scattering will be at different positions. So that's why splitting up of takes place, depending upon the speed of light. What type of light? Depending upon the speed of different colors. Okay, inside the glass medium is different, so that it splits up. We can't see this one in it splits up there also, but we can't see that. Why it will? I will tell you why it is. So next, what he consider is, okay, Newton consider. See, one prism like this and exactly the similar prism, okay, exactly same prism, and he put that one in an inverted shape, same prism, okay, in an inverted shape like this. Okay, base is here in this position. If it is ABC, okay, it is BC here. Base is it is in a ulta position, you can say ulta. Okay, he put like this, okay, and he observed the nature of the light, incident light. What he has done, again he took white light like this. He introduced, that is, whenever a white light falls on one face of the prism, first prism, then what happens? Automatically dispersion takes place, correct or not? So I will write for only 3 rays, for this one, and the emergent light will be what? Like this, correct? Emergent ray will be bending up of light takes place, and emergent rays will be like this. Now, if you put the one more prism on this way, on the way of the emergent light, then what happens? These, again the bending takes place here. Okay, again the bending up of light takes place. So that what is this? Reverse phenomena happens. See? Yeah, everything merges like this. Okay, again the bending up of light takes place and everything merges. And the emergent ray will be what? Emergent ray will be again the white color. So the phenomena of dispersion takes place in the first prism, and the phenomena of what we call recombination. Again, recombination takes place. All the dispersed light will again fuse together. Again, it forms a same one color, this white color. Again, emergent ray will be of the white color. Okay, bending up of light, splitting up of light takes place, dispersion happens. After that, what happens? this recombination of the 7 colors again takes place in the second prism. So this is how this is the observation made by Newton. That's why we can't see the different colors whenever you view through the sunlight. So that's what happens. Though this person happened, this acts as this is a parallel ray. So this is the two combination of two prism acts as one parallel beam, parallel glass plate. Okay, see, parallel glass plate, it happens, rectangular glass plate, like this happens, right? So if you add these two, what happens? It appears as if it is a one parallelogram are like this, correct? So that's why, so rectangular prism, in the rectangular prism, this is the case, okay? Two combination of two prisms makes up one rectangular prism. So that in the rectangular glass vessel, so that from that we can't see the dispersed light or the spectrum, okay? But though but it happens, okay? That's why this is the what? This is the illustration or the example given by the Newton to prove that, Newton only proved that, what is that? White color consists of 7 colors. White sunlight, okay? White color consists of 7 colors. Vibgaya, that is spectrum. That is a spectrum of light. Spectrum of 7 colors of different wavelengths. He showed one Newton ring also. Correct? Newton ring is what? He took one round color, what we call one disc like this, round color disc, round disc with which is marked equally with the all the colors, all the 7 colors like this. Okay, we can do this experiment also. See, what is this Vibgaya? If you paint like this, okay, Vibgaya. Now what happens if you rotate this disc with the help of something? Okay, if you rotate this disc with help of something, then what happens? You will see white color only, though it is made up of this disc is made up of 7 colors. But if you rotate continuously like this, you will see the white color. This type of experiment we had done whenever we are in a high school level. So this is actually Newton ray. We will call it as like that. Okay. So now it is what? What is the intention of Newton ray? He showed that white light, though it is white is color of the sunlight, though it appears light, but it is not light. It is a that is, it consists of a spectrum of light with 7 colors. Vibgaya. Okay. Now you might have seen clearly the Vibgaya in the natural phenomena, that is known as the rainbow. Correct? Have you seen rainbow? Everyone has. Correct? What happens in how the rainbow is formed? Kamanavalu in Kannada, they will call it as Kamanavalu, right? Rainbow. How the rainbow is formed? Here what happens? Usually you will observe rainbow during rainy days. So whenever rain comes and stops, okay, then the rain comes and stops, and whenever the sun appears on the sky, then you will observe rain. What is the actual phenomena behind this rainbow? That is also the dispersion of light. Okay, so it is a natural effect. How it formed? Appearing the suppose when white light means sunlight enters into the drop of the rain. Whenever after rain means raindrop in the whenever during the rainy days, raindrop will be there. No, accidentally somehow raindrop. Okay, sorry, somehow sunlight enters into the raindrop. Okay, this raindrop acts as a natural prism for the sunlight. Raindrop acts as a natural prism for the sunlight. Okay, so what happens here? If it enters means white light is there, sunlight is white. Okay, it enters into what? It enters like this and splits up into 7 colors. Same thing happens because raindrop acts as what? Raindrop acts as a one natural prism. So it is transparent. Raindrop is transparent, right? So it acts as like this. Then what happens? This is only 3 colors, 3 lines I wrote for my simplification. So now what happens here? What happens? One more thing happens here. This is what dispersion of the colors takes place inside the raindrop. Here it won't come here. It won't come back from this side. No. If it comes back from this side, you won't observe rainbow. Now what happens here at this is at this phase, okay, at this phase, okay, it happens the denser medium. This is a denser medium for that. So that at this phase what happens? total internal reflection takes place. Okay, total reflection also takes place at this place. Okay, this transparent one, so that here it is a smooth surface also, raindrop. So that's why it acts as a one glass surface mirror. So that here what happens, internal reflection takes place. If reflection takes place means what? Reflected, right? Okay, reflected, right? With all the constituent colors like this only. With all the constituent colors, okay, emerges out of the prism. Sorry, emerges out of the rainbow. Emerges out of the rainbow, making a beautiful picture of the rainbow. What is that? Which is having with a spectrum of 7 colors. Same thing as Vibka. Yeah, this is V. This is R. VGR we can write. So usually we'll write VGR, that is violet, green, and red. Okay. So but VGR also, we usually will take blue, green, and red. Why? Because so these are all distinctly visible colors. Okay? So it is this that is the 7 colors we will observe in the exactly will distinctly will observe the color in the rainbow. So all the 7 colors, correct? So what is the shape of this one? It will be like this because of what? This is the shape of the raindrop. So this is what? This is screen. Okay, the sky is the screen between what? Screen between the sun, our eye and the raindrop. Okay, raindrop is in between. There is a existent raindrop, and this sky is what? Screens. That's why what is the shape of the rainbow? It is like this because it happened inside the raindrop. Understood? Very, very important. Okay. So in this, what is the phenomena happens inside the rainbow? Here, what is this? One is refraction. Okay, bending up of light takes place. Next one is dispersion of light. Next one is total internal reflection of light. All these phenomena takes place. Okay, and again it is dispersed light comes out of this one. Again, refraction takes place. Okay. So, but what is this? Usually, rainbow is happened due to the dispersion of light only, you can say. So, but all these phenomena is possible. Okay, first one is what is refraction. Okay, next one is what? The dispersed colors will be there, and again the internal reflection will be there, and outcoming, that is emergent ray. Emergent ray is what? Emergent is the dispersed light, or it is a splitting up of light takes place. So it is refraction, dispersion, internal reflection, and then the dispersion. Dispersion, refraction, and dispersion. So this is how they will ask the question like this only. Okay, if you observe the raindrop, what actual phenomena takes place inside the raindrop? That is actually splitting up of light takes place due to this. Suppose if they give, okay, if they give dispersion, refraction of light, everything, so you can write all the above phenomena, you can write. Okay, but usually mainly, well, that is dispersion of light. Don't write only dispersion. You have to write dispersion of light. So these are the things that we discussed inside in the about the dispersion of light. Is it clear? Topic clear? What I told? Dispersion, and before that I told about the refraction through prism. So refraction through prism is nothing but what? Refraction through the prism is nothing but the dispersion. Now we will discuss some more phenomena. Phenomena means what actually? Some more phenomena means the natural things which is happening around us. So we can see that one daily or in between. So that is natural things. We don't have any control on that. Correct? Natural things it happens. Okay. So that natural things, that is known as phenomena. Okay. We will discuss all those phenomena taking what? Taking physics as a base reference and physics law, applying some physics laws on that. Okay. Now what we are studying is one more thing is atmospheric refraction. Refraction. What do you mean by atmospheric refraction? That I will tell you. What is the meaning of atmosphere actually? Earth's atmosphere. We know that many planets in the solar system will not have any atmosphere. That's why life won't exist there. Correct or not? So, but Earth has a thick atmosphere. What is the meaning of atmosphere here? So, Earth, suppose if it is Earth. Okay, I'm not good at drawing. Okay, so here it is. Suppose if it is Earth. Okay, Earth is covered with different layers of gases. Consist of many types of gases, moisture, and etc. And this is covered. Okay, I wrote only one portion. So this is covered with like this. Okay, and this is known as thick blanket of gases. So and made up of different types of gases, humidity, everything is there in that. Okay, atmosphere, moisture is there, everything is there, and this is not totally. We'll call it as atmosphere. In this atmosphere, different layers are there. Okay, you know that one, right? Lithosphere, barosphere, correct? So many stratosphere, many spheres are there in the atmosphere. Depending upon what? Depending upon the different layers are there. Depending upon the density. Again and again, I'm telling about the density. Density means what? How thick the gases are there in that one. Okay, so it is having less density, more density, like that. Okay, denser means. So the atmospheric layer which is near to Earth is what? Higher, denser than the one which is up far from the Earth. Due to this one only, due to this atmosphere only, we will life exists inside the Earth. Those things you know. Okay. So now what happens is, here, well, some phenomena will observe. No, that is like, okay, that is due to the atmospheric refraction. What are the examples? Example they are telling about the star. Okay, star. Twinkling of stars. Twinkling means what? Twinkling of stars. And that one I will explain. What is that twinkling of stars means what? If you observe we know that stars are at a very far off distance from Earth. Correct. If you observe star from, suppose if you are standing on Earth, it is like this. Okay. I don't know how whether it is visible or not. Okay, I'm writing one person. Okay, here on this. Okay, so here this, if you're watching a star from and standing on the surface of the Earth, what happens is, we know that stars are very far away from Earth. Suppose if it is the star here. Okay, so star. Suppose the star is like here in this position. So it is very far off. Now, if you continuously observe one star, then what happens? Sometimes it will be like bright. Okay, sometimes it will be bright. Sometimes it is dull. Okay, sometimes it will be bright and sometimes it will be dull. So that is what happens. Fluctuation here takes place in the brightness of the star. That is known as twinkling of stars. That is known as twinkling of stars. Okay. So now, and what is one more thing is that what we are observing. No, so if you are observing, that is exactly, it is, suppose if the star is exactly at the perpendicular distance from Earth, okay, then from our eye, then what happens? No bending takes place. That you know, right? At the normal, no refraction takes place. Suppose if it is at a slightly different from our eye, like this, if you are observing like this, then what happens? Bending up of light takes place. Correct? If you are observing means at the each and every level of the atmosphere. Again and again, I'm telling. Atmosphere is made up of different types of layers, and at each and every layers of the atmosphere, bending up of light takes place. Bending up of light means refraction takes place. Suppose if it is the star like this, okay, here it is bends here and this position, it is bends here at this position, bending, again bending, again bending, and again bending like this. So the person who is observing from here, it is actually, this is a position of the star, but the person will see the star like this, exactly at this position, at a slightly higher position. Okay, this is a star. Consider this is the same star. Okay, here it is also. But what is this? If you draw a straight line without the atmosphere, what happens? The light might have traveled like this. Okay, not perpendicularly. It is not perpendicular distance. You can write like this. Light might have traveled like this. Okay, so that what is this? The person might have that is person is watching the light star from here. That is, this is the that is slightly up, okay, when compared to the real position. This is actually, what is this? This is the real position, but person is watching the star slightly up, okay, and this is known as the apparent position. Apparent position happened because of what? Because of the bending up of the light ray from the star, okay, at the different levels of the atmosphere. Okay, this is the apparent position. Okay, this is not the real position. This is a real position, but it appears as it is rather than the where it is. Okay, it appears up at a slightly higher position than the real position. Understood? This is the refraction, atmosphere refraction. Due to this, what happens? The this one changes. Position of the star changes. And hence I told about the twinkling of stars also. Twinkling of stars also the same thing here also. What happens is the light will travel through different layers of the atmosphere with different densities and different temperatures also. We know that nearby the earth temperature is more. If you go far away from that one, temperature is less because of the atmosphere is less there. Okay, so that due to that one happens, that is the same thing happens here also. So that the stars will not appear bright always. It will be twinkling everywhere, all the time. So that is one case. Okay, scattering takes place actually. Yes. Next one, you may ask me, what is this? Why the planet will not twinkle light? Correct or not? So why the planet will not twinkle? Planet will appear as a same color, same position. If you observe Venus, it appears as a red color. No twinkling happens. So, always the same brightness. Correct? Why? Because planets are near to us. Okay, and here if it is near to us means almost from planet, almost from all the sides, the light will enter into the earth. Correct, from all the almost sides. Okay, here in the star is too far away from that, then what happens? Only we can see only from point source. As stars acts as a point source, means very small one, so that only one ray, okay, we can observe exactly one ray. Here what happens? Multiple ray will come from the planet, so that it won't be twinkling. So this is also due to the atmosphere density, a different density of the atmosphere. That is one thing. So these are all the things what I wanted. That is what I wanted to explain in this. So that is atmospheric refraction. Next comes what? Next comes yes. So next is the same thing I observed. I told no. Now I told about that twinkling of stars also. This is what. So this is due to the Earth's atmosphere with different different densities, so that twinkling of stars also takes place. Now, one more thing is, so many phenomena are many what we call many phenomena only we can say that is that happens due to the atmospheric refraction. That's why one big chapter they kept for the atmospheric refraction. Here it is. So advanced sunrise and delayed sunset. So what is this? Advanced sunrise and delayed sunset. So actually, what is this? Suppose if you are standing on the earth, okay, if you are observing a sunrise. Have you observed sunrise and sunset? Yes, I think everyone might have so. So suppose if he is observing from the horizon, what is the meaning of horizon? Diganta, so horizon. Okay, this is the one imaginary line. Okay, it is not an imaginary line. Just it will separate Earth from the sky. This is known as the horizon. Earth from the sky. Okay, sky and Earth. There is a line. Okay. Now, what is actually sunrise and sunset? Okay. So it is a horizon. Horizon is it is actually parallel to exactly on the line of our eyes. Usually, if we stand like that. So if you stand on the horizon, then what happens? Actually, what is this? Suppose below, that is sunrise means what? Sunrise means below the sun will come from below the horizon to up. That is known as sunrise. So sunrise means sun will move from below the horizon to up. Okay. And sunset means what? From up to down, bottom. Okay, up to down. So that is the sunrise. Sunrise means sun comes from horizon from down to earth. That is our assumption. So that we can see. The correct that we can see. Sunrise. Okay. Usually what happens is during the sunrise, so that is sunrise. If you observe, then again, what happens? Again, the atmosphere is there. Okay, around the atmosphere. Okay, around this atmosphere is there like this. Okay, same thing happens here also. What is that? Bending up of light takes place, correct? So that is what that is from the horizon. If it bending takes place here also, here also, here also, everywhere bending takes place. See, bending. This is a light from the sun, but it is bending takes place, and the person will appear. Person will see the sun like this here. But what is this? Actually, what is the position of the sun here? Actually, apparent position of the sun is here. Actually, person will see the sun here. Okay, actually position of the sun is here, but he will see the sun from here because of what? Because of this one only. So that is sun is still yet to rise. Okay, but person will already saw the sunrise. That is 2 minutes before only you can see the sunrise, though the sun is here only. You should come here, right? It will come here after 2 minutes, but you can see this one before that only. That is known as, that is also due to what? The scattering of, that is refraction. Okay, apparent, sorry, it is a atmospheric refraction, not scattering. It is atmospheric refraction here. And that is also due to atmospheric refraction. This is known as advanced sunrise. Though the sun yet to rise, you can see that one. Sun not came above the horizon, but we can see that one. So that is known as the advanced sunrise. That is actually apparent position. Actually, apparent position of the sun you can see before the sunrise. Same thing happens in the case of the sunset. Okay. Here it is sunset. Again, I will tell you. Sunset means what I told. It will go from up to down. Horizon is here. Sun will go from top to bottom. Means from the horizon, it will go from top to bottom like this. Okay. If he goes like that, then what happens? Actually, he will go. Here what happens is delayed sunlight. Delayed sunlight means actually you can see before. That is, you can see usually what happens is sunlight is delayed when compared to this one. So you can see that is early sunset. So sun is set. Okay. Still, that is, you can see this one. That is not a delayed sunset. Advanced sunrise and delayed sunset. Okay. So the sun sets early. So sun sets early. Sorry, sun sets later than we will observe. Okay, but we will observe before that only. Before that only sunset had happened, but sun will not set at that time. Okay, 2 minutes after that only he will set. This is the thing. What is the difference? That is the example for the atmospheric refraction. That is the illustration of the atmospheric refraction. That is, one is advanced sunrise and delayed sunset. Okay. So now I think you understood all these things, and I'm moving towards what? Moving towards the scattering of light. One more important thing is that is known as the scattering of light. Have you heard anything about scattering? Word like scattering. So this is also one different phenomena of light. That is known as the scattering of light. What is the meaning of scattering? Scattering means everywhere. The things we will scatter everywhere. Books. If you are reading means what? If you are reading means on the table, all the books will be like this. It is not in a proper position. Correct? No discipline. So everywhere it is scattered. That is known as scattering. That is the one more phenomena of light. That is known as scattering of light. So many things we will observe in the from the scattering of light. That is, what is that? Color of the sky. One thing is color of the sky is also from the scattering of light. And the next one is, you might have seen the color of the sun. Color of the sun is what? Red. Correct. Color of the sun is red at what? At the time of rising and setting, and it is color is white or yellow whenever it is at the exactly at the top of our head. Correct or not? So I will explain all those things. These are all the things due to scattering of light. What is the meaning of that's one more thing is that Tyndall effect. That is also due to the scattering of light. What is the meaning of scattering? So what happens is, again I'm telling, I wanted to explain the scattering color of the sky depending upon the scattering of light. Okay, taking the example of color of the sky, that is from the taking the phenomenon of scattering of light. What happens here? Again, I have to write the Earth with the atmosphere. In the atmosphere, okay, this is Earth and this is surrounded by atmosphere. In the Earth atmosphere, air molecules will be there. Okay, air molecules will be there. Okay, these air molecules, what will do? They will scatter the entered white light. So suppose from the sun, if it is sun, okay, sunlight is coming in this, which enters the surface of the atmosphere, then what happens? Scattering takes place. What is the mean? Suppose if you're observing from here, what happens? So scattering means what? Scattering means this air molecules scatter the incident light ray because of this, they are having the same wavelengths. What is that? So if it comes, no, it splits up, no, it splits up into 7 colors, that you know, correct? So which one is more, which will be bends less, and which will travels more? Red light will travel more. Okay, which will bends less and will travel more. And blue light is what? Here bends up here only, and it will be scattered. It won't enter into the atmosphere. Okay, there only it will scatter. Scatters means what? Here, everything goes here only. All the molecules will scatters here. Blue molecules, so blue light molecules will be then they'll scatter due to what? Due to the air molecules. So that air molecules scatter the blue light. Very, very important. But it will enter all the colors like red, yellow, and everything enters into the earth, but not the blue. Blue, why? Because it bends more, so that it will scattered by the air molecule, because the wavelength of the blue light is almost equal to the wavelength of the air molecule. That is very important. So here it is. That's why what happens? We can observe the color of the sky as blue. Why the color of the sky of blue is like this? It has an atmosphere. Earth has an atmosphere. In the atmosphere, air molecules will be there. And whenever the white light enters, then what happens? There are 7 colors are there. And in that 7 colors, blue will be scattered more from the air molecule. So that the light, where is that? Blue color will be scatters, means spread. It will spread everywhere. So it won't enter into the atmosphere. Only red and yellow enters into the atmosphere. So that the color of the sky blue is blue in daytime. But what happens if the astronaut, okay, who is astronaut means what? Gaganayatri. In Kannada, it is Gaganayatri. So if he observes the earth from the earth, it appears blue. Okay. If you go beyond earth, then what happens? No color. Means colorless means black. Everywhere it is black. Correct or not? So due to the atmosphere of the earth only, this scattering of light takes place, and the color of the sky is blue. Okay. Now what happens? Again, the same thing I wanted to explain. This one, scattering of light, color of the sun. Whenever sun sets, okay, sun sets means sun rises. Okay, sun rises or sunset. He is more far away from the earth. Okay, he is more far away from the earth. At that position, what happens? Again, due to that one, sun rays comes here. Sun rays comes here, and what is this? Sun from the sun, light ray from the sun. Okay, it enters. It is actually, we told it is white light. Correct? The slant light enters like this, white light, and it is splits up into 7 colors due to different different density of the atmosphere, different color splits. Okay, then what happens? Refraction takes place here. Different colors will be there. Again, here also what happens? Blue color will not enter into the atmosphere. Only which one is having more speed? Red, right? Red can enter into the earth surface. Understood? Due to the scattering, what is this? Blue is scattered everywhere, but red is not that much. That's why it enters into the earth. That's why you can see red or orange color. So red and this one. So red and red color of the sun will do both the sides, both the time whenever it is sun rises and sunset, because of the longer range. Okay, scattering is the more in this case position. Okay, now whenever the sun is at what? Sun is at the top, it is having a less distance. The distance between the atmosphere and the sun is less, so that it won't scatter. So that's why it enters the white light like this only. So no dispersion takes place, nothing will happen. So you can see at the top, at the 12 noon, in the afternoon, 12 noon or something, if you see the sun, which is exactly at the top of our head, then it is color of the sun is what? You can say yellow also, but it is actually, it is white. Correct or not? So yellow or white. So that is because of what? Scattering is least in this position. So but the scattering is more whenever the sun is away from the earth. So red is scattered more in this case, and here it is no scattering, so that white light exactly enters into the Earth's atmosphere. This is about the color of the sun. Color of the sky also, color of the sun also. One more effect is there, that is they explained here about the Tyndall effect. Tyndall is what? Tyndall is the name of the scientist. I will explain that one. So I will explain this one now. Tyndall effect, name of the scientist. So actually, if you see, okay, can you see the light ray? You can't see the light ray, okay, because light ray will make us to see the things, but normally we can't see the light ray. But whenever you will see the light ray, if you enter a dark room, okay, if there's a dark room is there, from in that dark room there is a small hole, okay. In the daytime, if you enter a dark room, if there is a small hole from the window is open, small window is open from the outside, then what happens? The light ray will fall like this. Correct? Not will be we will observe like that. Correct? Not in a one straight line, it will come. And around that, you can see clearly the dust particles like this. Correct? Scattered everywhere. Correct? So this is, you can see exactly the path of the light. Because of what? Because of the, you might have seen this one everywhere. Correct? Not so the light ray enters in from the top, or that is a roof of the building. So this will be like this. Correct? So here it is. What happens is here, in this case, it will enter like this, and it will end. If you enter means a part of the light is illuminated, you can say. Illuminated means you can see the surrounding position. It will be like up to some extent only. Surrounding position, we have dust particles, moisture, something you can see. Correct or not? Before that, no, in the normal room, no, nothing. You can't see these things. But now, that is the dark room, if it is the path of rays entering, then what happens? Around that, you will find this type of what we call scattered particles. Okay, this is known as this is observed by scientist Tyndall, and this is known as the Tyndall effect. What is this? This is due to what? This is the where if you take the dust particle and all, if the atmosphere and all, then nothing will happen because of the size of the particles. So this Tyndall effect, or the scattering of light. Again and again, I'm telling, scattering of this Tyndall effect is also one poor phenomena due to the scattering of light only. Here, what happens is, so this is not that is a scattering of light. Tyndall effect is also from this scattering of light takes place due to depends upon the size of the scattering molecules. Before that, I told, okay, if the size of the scattering molecules is matches with the size of the entering size of the molecules, okay. Matches means almost equal, okay, almost equal to the wavelength of the entering light, okay, then only this type of scattering of light takes place. Otherwise, no. Everywhere, no, scattering will not be happen, right? This is if the dust particle is there, dust particle, whenever you compare to the dust particle is more, size of the dust particle is more when compared to the size of the air molecule. In the dust particle, what happens? Absorption of the light takes place, and what is this? Emission of the light takes place after scattering. But here in the air molecules, what happens? Directly, the scattering of light takes place with the 3 colors. So with the 7 colors, the scattering of light takes place here. So it is because of the size of the molecule. Size of the dust particle is more when compared to the size of the air molecule. So that in the air molecules only scattering of light takes place, not in the dust particle, because of the size. Again and again, I told you about the size. Okay. So these are all the things. Very important is, in this phenomena, in this what we call, in this section, in this class, in this session, we discussed about what are the things. So almost all the phenomena of light. So before that, you know that reflection of light, correct or not? So now we studied about the refraction of light through prism. So next one is what? Next one is, I explained about the dispersion of the light. Very, very important phenomena. Dispersion of light and also scattering of light. Okay, so these are all the things that is there that we discussed today about these things. So now you can ask, this is that is refraction of light, dispersion of light, scattering of light. And what is this? What are the expected questions? We will discuss now about the expected. I think whatever I explained, you understood, right? These are all very important phenomena. So these are all very important natural phenomena. Daily you will observe, like twinkling of stars. Daily I will observe. Frequently will observe the rainbow formation. But what is this? We gave the laws, or the why actually it happens. Okay, from the physical, that is a property of the light, that we explained today. Correct or not? You came to know about the what is actually behind the formation of a rainbow. Why stars will twinkle, not the planets, and why the color of the sun is red during the sunrise and sunset, and what is the delayed sunrise and advanced sunrise and delayed sunset. Okay, so don't get confused with that pattern. So now it is what now we studied all those things, and these are all this all the natural phenomena can be explained on the basis of the different properties of light. That also I told you. So next one is next what we are studying. Any doubt is that for to observe all these phenomena, so I will take the external portion of the eye. Okay, so to observe all these phenomena, the vision of the both the eyes of our human, okay, both eyes of a human are very, very important. Vision means both the vision is perfect, then only we can observe properly all these phenomena and the colorful world also. That's the topic is colorful world. What is a colorful world? Here it is a rainbow is a colorful, dispersion is colorful, correct? So sun color of the sun is colorful. That so we can observe all these things through our eyes only. Eyes, I will last class only we studied the different properties of the different parts of the eyes and different functions of the parts of those eyes. Very important. So I told some questions. What are the expected questions on human eye? Now I told you some expected questions on the topic what we discussed today. There is some phenomena like refraction, dispersion, and scattering of light. Correct? What are those? Let us list some of the important questions. Maybe they will ask like this. What is dispersion? Commonly called question. Dispersion. Okay, then what is this? Newton's experiment also. Based on the Newton's experiment, you have to explain that is white light consists of 7 colors. Okay, Newton's experiment. One is what? First, what happens? First, the dispersion takes place, splitting up of light takes place due to the refraction of light. Then what happens? Recombination. Okay, fusion. Again, recombination means everything will comes together. So recombination also takes place due to the other prism. Okay, there's also double refraction takes place here. Correct? Double dispersion takes place. Next one is what? Next one is dispersion. Next one is what? You can expect the question from Tyndall effect. Why it happens? Okay, and what is this? Rainbow formation. So most commonly called question not only in 10th and all, so in a competitive examination also. Okay, competitive examination also they will ask about white stars twinkling of stars, not the planets. Okay, not only in 10th standard only, they will ask that's also. And one more thing is color of the sky is blue. Color of sky is blue. Why? Because of the scattering of light, because of the air molecules will scatter the blue light more. And what is this? It won't enter into the earth, but there only it will scatters here and there. So that what is this? Whole blue sky appears as if it is blue. Okay, okay. If it is no atmosphere, no color. Means color means what? Blue, dark only everywhere. Okay, so no atmosphere. That is due to the air molecules of the Earth's atmosphere will scatter the color like this. The more color as a blue more. And what are the things which enters? Only the light rays like red and thing, everything enters into our. That is the very, very important thing. Next on the same thing, on the scattering only, what is they may ask what is this? The rising sun. Okay, color of the rising sun. Rising sun, red. Correct? White. Rising and setting sun. Okay, so rising and setting sun color is white. But that also it is possible. Next is explain about advanced sunrise and delayed sunset. Okay, advanced sunrise means what? 2 minutes before only, okay, we can see the sun rise. Already it exists in that position, okay, but it will actually to enter into that position. So what happens, that is known as actually the apparent position of the sun, not the actual position. Actual position when it comes after 2 minutes only. This is known as the advanced sunrise, correct? Sunset, that is also, so we will see the sun that is before the sunset. So that is before that one only. Okay, that is the delayed sunset. Okay, so that is already we will see sun is set, but it is there in that. Okay, correct or not? So that is delayed advanced sunrise and delayed sunset. Next is Tyndall effect. I told, right? Okay, this is all the things, okay, the expected questions, and they will tell this one also. Draw a neat diagram of the triangular prism with what is this? You have to mention the parts. What is this? Incident ray. Sorry. Incident ray, that is this is what this refracted ray, it is an emergent ray. These things you have to explain. And what is this? 7 colors, it will split up also. So these things you have to explain. So before if you take one, okay, so to avoid this confusion, okay, so whenever you will take enter a white light, enter this into anything, so that is splits up into that one. It's 7 colors. To avoid that, we will take what? A single, that is monochromatic light. What is monochromatic light? It is made up of single color. Example, laser light. Laser light. Okay, laser light. Okay, if a beam of laser light travels inside the prism, then what happens? It won't split up into 7 colors because it is a white light. It is having only one color, not a spectrum of colors. White light only consists of spectrum of colors. Laser won't gives 7 colors, correct? Because it's known as the monochromatic light. So while studying the phenomena of reflection and refraction and everything, you use the word like MC light, that is monochromatic light only, to avoid this confusion. What is that? Way to 7 colors and all. So you will consider for simplification monochromatic light only. So if you use laser light, nothing will happen. That is this is the expected question also. If instead of using white light, if you use laser light or any monochromatic light, what is the emergent ray of the prism, emergent ray from the prism? Okay, what is that? It is nothing but the laser light only, single color ray. What is the laser? Red light only, right? Same one color only, not 7 colors. Okay, only one color. So instead of using laser white light, we can use laser light also, so that the beam will be what? Emergent beam will be of same color. No splitting of us, no spectrum. You can't expect any spectrum from the monochromatic light. Okay, example is laser light. So these are all the things what you can expect in the examination. Okay, many questions you can expect for 1 mark also, 2 marks also, 3 marks also, 4 marks also. So what is, we have to explain the properly, you have to explain all the phenomena, correct? So if you have the emergent ray, if they ask for to write the diagram of this one, so you have to explain what? Taking the monochromatic light only, the incident ray, the incident ray, okay, the refracted ray, emergent ray, angle of deviation you have to mark here, angle of emergence you have to mark here, everything they expect. Okay, so these are all the things what I wanted to tell in this session. Okay, any questions? Any doubt? Anything you wanted to ask? Okay, I this session help you, and that is the topics what I discussed is having no doubts, correct or not? So I thought I'm thinking like that I will end this session. Thank you.